All right, some announcements. In case you didn't see it, I did push back homework 2 by a week. Instead of being due tonight, it's due next week. I don't like to make things due intermittently. I like to, when I can, keep to that Wednesday deadline. So I could have made something due at the end of the weekend, or it just doesn't make sense. What I can say, and I said this in the announcement, is I may assign the next assignment before this assignment is due for the following week. So you may have a couple of assignments assigned for a few days, because we're going to cover on Monday what would allow us to start work on the next assignment. Okay. We have review today, potentially tomorrow. We'll take the temperature for that at the end of the class period for how prepared we feel. We'd like some more practice on. So I want to start today asking if people have any questions or clarifying questions on the study guide. As you were reviewing the study guide, if you had a chance to do that, were there any points that were unclear? Were there anything you didn't know what I was talking about, that you didn't know how something that I had mentioned ties to how an exam question would be asked about that? Other generic questions about the structure of the exam, the kinds of questions, how to prepare, just general questions like that. And as we exhaust those kinds of questions, then I'll dive back into the practice problems. And we can extend that to tomorrow as needed. But any general questions on exam prep or study guide before we start? Yeah.
You get a sheet of notes, right?
Yes, I do. I forgot to mention that, but yeah, in the syllabus and in the study guide, it says you get a sheet of notes, and that can be front and back. I'm not going to collect it. You can put anything you want on it. I will be writing and designing the exam to make that sheet not necessarily as useless as possible, but so that the answers to the exam questions aren't directly on your study sheet. This would be something that you need to know as prior material or as just kind of a how something works so you can interpret it on the exam. I don't want there to be much memorization. I don't want anyone in here to be thinking, oh, I wish I had memorized that before taking this exam. That is not ever an outcome I like. But anything that you would like to have access to on that study sheet, I'll be making problems that have you using that information rather than just copying it over. Other questions? Yeah.
Will we have an opportunity to see what we got around the home?
Yeah, that's another announcement I meant to. I checked in with graders and gave them a deadline of tonight to return that to you. So you should have your first assignment back by tonight. Again, when there's a 4+ student class, that takes a while, and I know these graders well. They provide solid feedback. They're going to take the time to look at your answers, find any inconsistencies or issues, and report those to you. So it should be good feedback to study off of. If that's not the case, then come to me and I can clarify any of their comments, any grades without coherent or in-depth enough comments. Also, if you disagree with any of the grading, I'm happy to hear any of those arguments. That's always the case for any assignment or exam. I want to at least have the opportunity to explain to you why the grade is what the grade is, so that you understand and can move forward with that. Or if you have a reasonable argument for why the grade should be changed, then I can either make that change or route that back to the graders so that they can learn differences between how they're grading and my expectations. So before just holding that in, like, that's the grade that I got, that sucks, or I disagree with it, and be frustrated by that, at least come talk to me. Even if it's just for clarity, I'd still rather have that conversation with you than not. Good questions so far. What else do we have? People just want to get into the problems. All right, let's do that. And if you think of a question, I will come back to questions either at the end of this class or at the start of the next class. So feel free to take some time, come up with some questions, and we'll address those as there is time. All right, so we voted before class to do substitution method first. And then, so I have 4 problems for us for today. I don't think we'll get through quite that much, but we will see. So I chose substitution method problems in a similar way that I would choose them on the exam, where the master method does not apply. If I generally ask you to solve a recurrence, I'm not going to say solve it with the substitution method to solve it with the master method. It's on me to come up with a problem that if I'm testing the substitution method, I should give you a problem that requires the substitution method. If there is a shortcut and then I tell you you can't use the shortcut, that feels bad. So I will either ask you solve this recurrence however you want to, and if the master method applies, you may use it, or I will give you one where you can't use the master method and say solve this recurrence, and then you would have to use the substitution method. But here we go. Whenever we see a t of n equals t of n minus something, the master method won't apply. The master method is only for a t n over b plus something. So we can't apply it here. Yeah.
Actually, I have a question. How soon are these slides gonna be posted afterwards?
These I can post right away.
Oh.
In case you'd like to look at these more, practice the same kinds of problems, review the lecture video while looking at the slides. So I'll try to get this lecture video posted today as well. For some reason it's not up when you're looking for it, send me an email and I'll get it up as soon as I can.
Thank you.
But let's start with a few minutes to work on this. Again, you can work on this individually, you can work on this with groups, whatever would be useful to your process to learn this. If someone else comes to you and says, I'd like to work in a group and you'd rather work solo, feel free to let them know. That's just better for your process. You'd like to test where you are. But you can imagine this is a recurrence that is very similar to a recurrence that I would be comfortable throwing on an exam. You absolutely can. I would leave it up to you. So the book uses a lot of proof by induction. I am perfectly fine if you do a substitution and then some analysis to figure out what the runtime is, as long as that analysis is thorough. You may absolutely use induction. It may just be quiet. People online are saying no audio or no video. Is that the case? People can't hear me? Interesting. Yeah, I'm just giving people time to work. How are we doing? Show of hands of anyone who'd like more time to work? Couple people? Feel free to keep working for a little bit while I talk to the rest of the class, but how does, for those of you who are done, how does this feel as an exam question? That feel something does this feel doable? Are you confident in your answer?
Feels doable. I'm like mostly confident.
Okay, good. Others?
It feels doable, but then I like hit a roadblock, which is, I just think it means I need to study a bit,
Okay.
it does feel doable.
Yeah, as I go over this, I'm gonna try to go through some intuition as well as the process for solving it, so that you get a sense of kind of are you on the right track? Also, a good place to start, which should give you a way to verify that the answer that you derive makes sense. How are we doing now? Anyone want more time to work? Why don't we go over it? So, intuition. How many times are we going through this recursion? What is the recursive depth? Yeah. N over 2? How do we get that? Or how do we know that the recursive depth is N over 2? How many times do we subtract 2 from N before we're at a base case of T of 0? We would have T of N, N over 2, not N over 2, N minus 2, N minus 4, N minus 6, N minus 8. By the time that reaches N minus N, that should happen N over 2 times. Each time, we're going to be taking the value of whatever's in this T and squaring it. We can come up with a ceiling for that reasonably quickly and say that every future time this N over something, or this as N minus something is going to be less than N. But imagine that we're just N the entire time. So instead of, we would have N over 2 copies of T of N. We agree that the solution to this is going to be faster than that. That kind of creates an upper bound on the runtime of this function. When we have T of N minus 2, that's going to be N minus 2 squared here. That is less than N squared. The next time we'll have N minus 4 squared. That's less than N squared. N minus 6 squared, that's less than N squared. So if we had N over 2 copies of N squared, what would that order be? We would have, at the end of this, N over 2 times N squared. What does that become? N cubed over 2. Here we have a constant, so this is in theta, this itself is in theta of N cubed, which means that this, since it's less than that, is in big O of N cubed. So we should refer to this as in big O of N cubed, but that's not a tight bound. If we're trying to solve this recurrence, this at least gives us, if you go through this process and derive N to the 4th, or 2 to the N, or something that is bigger than N cubed, you should immediately second guess yourself and look at your process. Because intuitively, your answer doesn't match with something you can look at this problem and just quickly see an intuitive upper bound to. But let's go through the work and see if this is in fact theta of N cubed, or if we can derive a lower order term. Intuitively, anyone have any thoughts on whether this is going to be cubic or something that is faster than cubic? How would you intuitively think about that as we replace this N over 2 copies of N squared with N over 2 and then N minus 2 and then N minus 4 and then does that end up cubic or does that end up faster than that? Help you with the intuition. It should stay cubic, and the reason it should stay cubic is that the proportion, there's going to be a proportion of these that are based on N before we get down to something that's reasonably constant. There's going to be a number of these that are proportionate to N. So that is going to keep this adding an order to this N squared. we don't reduce this to a different order, but to see that happen, let's actually draw it out. So when I see this, I intuitively think theta of n squared and n cubed. But for a couple of reasons. So let's draw this out as a sequence of substitutions. So we can start with referring to t of n. Let's start by solving for t of n minus 2. So t of n minus 2 is t of n minus 4 plus n minus 2 squared. Do we all see how I derived that? Or how I got that? Just substituting this n and n minus 2, making a substitution of n minus 2 for n. Wherever we see an n here, we're going to replace this with an n minus 2. So this n minus 2 becomes n minus 2 minus 2, which is n minus 4. And this n squared becomes n minus 2 squared.
Wow.
So that is a definition for t of n minus 2. So let's actually go plug that in. Where we see t of n minus 2 here in t of n, we're going to replace this with the right-hand side. And we can refer to this now as t of n equals this entire expression in that place, t of n minus 4 plus n minus 2 squared. And now we bring down the plus n squared from before. Now we have every aspect of the t of n, the entirety of this right-hand side, replacing the t of n minus 2, and we brought down the n squared as well. So that is another equivalence for t of n, but now we've referred to it in terms of t of n minus 4 instead of t of n minus 2. We could take this a step further. Let's come up with a definition for t of n minus 4, because we want to get rid of this term and replace it with a term that's closer to a base case. So t of n minus 4 is t of n minus 4 minus 2 plus the n minus 4 squared and bring down everything from before, from our t of n. This is just the t of n minus 4. We don't want to do that yet, but when we relate t of n, we're going to bring all of that down. So we have t of n now is the t of n minus 4. We go back to this step, replacing the t of n minus 4 with its right-hand side. So we have t of n minus 6 plus n minus 4 squared plus bring down everything else. N minus 2 squared plus n squared. Do we start to see a pattern emerging at this point? That pattern hopefully is intuitive when you look at the t of n minus 2 plus n squared. We're just now going to be coming up with a sequence of terms where we start with n squared, n minus 2 squared, n minus 4 squared, n minus 6 squared, n minus 8 squared, all the way down to n minus n squared. 0 squared is 0. That's going to be where this t term terminates. So this entire expression without the t of n minus n is now at this point just nothing here. And 0 squared is 0. So this term drops at t of n minus n. So we could now state that t of n is this sequence on the way down. So we could start, I'm just going to flip these terms so that it looks more like a progression downwards. And eventually this is going to be 2 squared as the last term. Because as soon as we get down to 2 minus 2 squared, that's 0 squared, which is 0. Granted, this could either be 2 squared, but if n is odd, this could also be 1 squared. We don't know if n is odd or even. But it's one of those two terms that would be the last term in the sequence. How would we turn this into summation notation? That's probably a good step or something to think about with regards to taking this entire sequence and just saying this is some sum. What is, how can we relate this sum to the sequence that we have here? What is that? Let's use a variable I, representing the current term that we're looking at.
Where would we start?
Could be from I is equal to 0 up to
N divided by 2 minus 1.
I'm actually gonna say, yeah, from I equals 0, we want to make sure that we want to refer to the exact what's happening here. So the termination at this point is at n. So we could either go up to n over 2, but since the last term we want is n squared, what do we want to do for that? Since we see that basically we, at the end of this, divide the whole thing by 2 because we only take half of these terms, we can actually factor that into just a half going up to n. Then we can take this as I squared as the only thing that we're doing. We agree that that is the same sequence that we have here.
See it?
So if we expand this, how could we show that this is cubic? Where is the intuition that this is cubic?
It's a sum of squares.
Yeah, so it's n terms that are squares. So this sum will evaluate to n cubed. It's a term based on n cubed. We know exactly what that term is. If we were summing from I equals 0 to n of I, what would that look like? That's 1 plus 2 plus 3 plus 4. We've seen that one before. If we square each of those terms, we can see that this half isn't going to matter. That's going to be a half based on whatever order this is. So we can basically ignore that half in terms of the actual order that we're going to represent. And this will just turn out to be theta of n cubed. I kind of shortcutted to that point, but you could draw this out to say that this is 1 squared plus 2 squared plus 3 squared plus 4 squared plus, and you could draw out from there based on the difference between that and the sequence that we've seen before, that this will in fact be theta of n cubed. You will get most of the points on an exam if you relate the sequence, and especially if you can create the sum. Even if you can't solve the sum for an order, just the fact that you were able to do this, there are equation solvers out there. It's nice for you to know how to do that, but it's not going to take you that much more time to go Google what order is this sequence in. I want to build the skill where you know how to do that, and that is intuitive. But the main outcome of this class, from my perspective, is the ability to break down this into that. That's the real skill, is being able to analyze the order. The internet exists. Some other professors are still living in the pre-internet age. The internet is a resource. We should use it.
I think I'm gonna probably try to find some sort of random substitution method problem generator to force me to adapt. I don't know if I can even find something like that if they have it on the internet, but it's worth looking into.
So I think this is exactly what I have. I have solutions prepared for each of these, and I think it's on the right here. So I'm going to get rid of this for the moment. And
At least I understand
this is
better.
our solution.
Yeah,
That is exactly what I wrote.
sure. So, all right. Well, I got a lot. Wait. Oh yeah. Oh, I equals 1, not 0. Okay, that's good to know.
At I equals 0, what is 0 squared? It's 0. It doesn't
Yeah.
add to the fact that I equals 0 or I equals 1 does not change the evaluation of the sum, whichever one you put there would be correct.
All right. Well, I'm just glad I'm get my observation on it.
Any questions on this derivation or on this result? Yeah.
When I did the summation here, I wrote n minus 2i, like that entire term squared, and I equal.
That would also work. It's a little more challenging to evaluate, I feel like, but it's not wrong.
No, it isn't. I almost did the same thing too. I only missed the n squared part, which was my fault, so.
How do we feel about a problem like this if this showed up on an exam? Did you get a right answer? Did you get a reasonably close answer?
I was closer, not quite.
Looks like we could use some more practice. That's why I have another problem.
This counts all of that.
So is it wrong to find like a function like based around k? Because that's what I did. Like I didn't do any like summation thing, but
What is K in this case?
I don't know. I guess it would be like the equivalent of pi.
Yeah. Yeah, in this case, you're doing like an n minus K, and eventually you find this is the general eighth step of the process. You can absolutely do it that way as well. A couple of my examples from lecture followed exactly that logic. And then you find the n minus n case, and then you can plug in and solve. There are so many ways to do this that I'm not going to specify an exact sequence of steps. As long as you have a sequence of steps that leads you to an answer, I'm not the kind of person who says solve it my way, and if you don't solve it my way, it's wrong. Solve it a way, and as long as there is correctness in your approach, don't care how you solve it.
Okay.
Could be with substitution, deriving a summation, could be substitution, eventually substituting a k in and finding a general formula, could be with induction. Any of these processes will work. Right. Let's dive into a second one.
Fascinating, a little different, if I'm honest. Now I get it. Fascinating.
Question. Clarification. Answer. Nice. We have an answer already. That's awesome. Let's give people a little bit more time to work, but if you'd like me to check your work, I can go over there and take a look at it.
Whoa. Okay, so this goes on the bottom. Where does it end? That way. No.
Eventual answer. Yeah.
It's-
Yeah, you can absolutely do that to figure out what. So T of n minus n is gonna be. To do a substitution.
Why is there in the do always need that?
You have terms of one over n minus k for all k from one. The sequence you're left with. So what is that sequence sum to?
Alright. Okay, fascinating.
Oh.
Interesting. Oh.
Yeah.
Yeah. I started just. This, but I. One on its own, you never divide anything.
This is correct. This is not. You have absolutely perfect work to that point.
More to it than I realized, isn't it? No.
I don't know. I mean, you have a really good, you have a good summation right there. That summation is correct. What sequence does that summation represent? And have we talked about, is there a way to visualize how that sequence grows?
Oh. I think I see where you're going.
Right there. Yep. That'll be right there.
How far does yes further after that?
Is this is,
Oh, we are doing like, but, oh,
so that's the correct sequence.
no.
If you are.
Page. You didn't exactly have the wall.
So basically,
Why did
you have
negative one?
is curiosity is very interesting.
That's. That curve as the.
Oh, no, like, I'm at the I equals -1. I was just curious. Hey, don't worry about it, so let's see. This-
It's gonna be fine for the most part if people leave it in that form. If you know how to take the integral over X, then you end up with an upper bound. And it ends up actually being a tight number, but leaving it as just the,
If I'm looking at this, you think how much of
I'm not gonna expect, if I threw something like this on an exam, it's already a bit of a stretch. I would say leave your answer in the form of a summation. Because Calc 2 is not a prerequisite, of course, so if some people need to do that. I would give it extra time, but I would not expect that people say.
I think it is a lower balance. Or just tight. Oh. Oh, yeah. It's not.
Would.
Well, I think you have a good ideas. To be honest, I just made it breaks up down.
A lot of those or particular all of us. Certifies, I have to know. It is something that is not something because it's a regression that we haven't talked
Oh,
about. What's the full points? Okay, solution. You can plug in that solution. More solution.
Oh. If you think about it, we're going about this place. We're going like the end of turn. I could, I think we more.
The only one I know. It's like, okay, Canadian fan. So I'm not gonna lie, when you started doing that, I was. Oh. Again. It's just hard work. Where, this 1/n term, this becomes 1/n minus 1. At this stage, and then you get it with 1/n minus 2.
No, you're-
So it does instead of have 1/n minus 2. I see. Series.
Yeah, so.
All right, I want to go over this just because we are getting close to out of time. Right. And I didn't want to get into, 5 minutes. This is how it feels like from my perspective when I'm presenting and busy the entire time. They used to have to sit there and listen, and it seems to take a lot longer when you're engaged and working for the entire period. 50 minutes feels like 10. I don't know how 50 minutes elapse every class period, honestly.
Yeah.
It does not feel like, it feels like 10. Whenever I'm in the student's shoes, 50 minutes feels like an hour. and 50 minutes.
Are you gonna do this again tomorrow?
Yeah, so we're definitely doing this tomorrow, and I want to go over some probabilistic questions. I'll see what else I can find as well, but let's talk about this. So intuitively, we can get an upper bound just like we did before, by just assuming that this stays n the entire time. What's the recursive depth? N. We're gonna get, we're gonna do t of n minus 1, t of n minus 2, t of n minus 3. There are gonna be n of those before we get t of n minus n.
Yeah.
So there are n copies of adding 1/n. That's going to change. It's going to be 1/n minus 1, 1/n minus 2, 1/n minus 3, etc. But as if you just assume this always stays n, then we end up with n times 1/n, which is just n, which is in,
Oh,
since this is an upper bound, we're going to leave this as a big O.
okay. So you were right.
But it's not n. This gives you an upper bound, but this is one of those cases where if you stop with the intuition and just leave it at that, your intuition will be lying to you. This is why we take that upper bound, but then we also have to go through the steps to verify that upper bound is tight. In this case, it is not a tight upper bound. Let's see why. If we're going to sum, we said that, let's just plug this in so we can see the full work. T of n minus 1 in terms of T of n minus 2 is going to be T of n minus 2 plus 1 over wherever we see an n, we're going to replace it with an n minus 1. So we can plug this back into T of n as T of n minus 2 plus 1 over n minus 1 plus 1 over n. We continue this process and we see that we're going to create 1 over n plus 1 over n minus 1 plus 1 over n minus 2 plus 1 over n minus 3. So we end up summing the harmonic series. This is the sum from I equals, we can say 0, we can say 1, 1 over 0 doesn't make sense.
No.
1 over n minus n becomes 1 over 0, so we probably want to start this at 1 so that we don't get a divide by 0 error. To n of this is now, we could say n over, or 1 over n minus I, but since this is the same series that's flipped, we could just say 1 over I. And now we're adding the terms in increasing order instead of decreasing order, but it's the same sum by the commutativity of addition. Does that make sense? Whether we go from 1 over n to 1 over n minus 1, n minus 2, or start with 1 over 1, 1 over 2, 1 over 3, 1 over 4, all the way up to 1 over n. Same sequence, just in a different order. This is just a simpler expression to denote here. So this becomes the sum of the harmonic series. Yeah,
Could you put n minus I? Would it make?
you could.
Okay.
It would be absolutely right. But it might be just a little bit harder to see that this is the harmonic series. And so if you graph 1 over x, what does that look like? We really only care about the upper right quadrant.
Yeah.
What happens down here doesn't really matter. But
It grows really slowly.
we have
Yeah.
1 and 1, and then it looks kind of like yeah, that.
That is
I'll call that good. Second grade good, but adequate.
Yeah, you're right.
So what's happening here continuously is fairly equivalent to what's happening discretely. We're going to say at each one of these intervals, what is this value? And we're trying to add the value that is here with the value that is at 2, with the value of 3 and 4 and 5 and 6. This maps to the concept of the area under this curve continuously. So you could take an integral. The question is the integral going to be greater than or less than? If we look at taking this chunk and then this chunk and then this chunk, is it an overestimate or an underestimate to the area of this curve? The curve is an overestimate of the discrete value. The discrete value is an underestimate of this. So if we were to take the integral of 1 over x, it would end up being a big O because it is an over approximation. But we can also prove that that is a tight fit. It's close enough that it doesn't change the associated underlying order. Anyone off the top of their head know what the integral of 1 over x is? Yeah?
Log it. Or natural log it.
Log x, so we're replacing x for n here, but yeah, it is the natural log of n. The source that I use for this just uses LG for some reason, but this should technically be ln, the natural log. But yeah, the solution that we see, we end up taking this integral, we see that it's less than or equal to the expression that we're going to use here for calculating the area under the curve of 1 over x, which becomes the rest of these drop. And we get theta of, this should be the natural log of n, but that's order-wise equivalent to log base 2 of n.
Why the 1/2 part? That's
It ends up being because we're starting this at 1. When we start this at 1, we start from 1, we go to n minus 1 instead of n, and end up having, don't worry about the halves, they drop. If I'm solving this, I'm just saying it's equivalent to the natural log and call it a day. Yeah.
For the initial intuition, what n times 1 over n?
N times 1 over n.
Yeah, for the very first part of it when you try to guess.
Yeah, n over n would be one.
So would it be n times one over n equals one equal?
We have n copies of one over n, so we end up with n.
Oh,
N copies of, yeah, if we do it like that, then it looks like it's. Yeah, no, this does come out to be n.
We get T1 plus
Yeah,
the harmonics.
yeah, plus the harmonic, yeah. That is exactly right, but we're a little bit over, I would not expect you, I mentioned this to a couple of people, I would not expect you to be able to do the end of this. If something like this showed up on an exam, I would say leave your answer in the form of a sum, or leave your answer, solve it if you'd like to, but to get full points, you would not need to convert this into an order. Leaving it as, this is the harmonic series, would be good enough. The only time I would expect you to know is if this is some expression we've seen in class, this is some relation we've seen in class.
Alright, thank you.
So we'll do probabilistic reasoning tomorrow. You know, ask some more questions about the study guide, first thing tomorrow as well.
Alright, well, yeah. You know, I got all of this, we got kind of like the last time, I got to speak a lot of.
Yeah, this is the general fate. So now we just have to plug in before and figure out where the T of n of that phrase, but I already tried that with every thing, one to n of 1 over n minus k minus 1, or every k of n.
Little
So
time.
I'm needing to go another step further.
Yes.
Okay.
Basically have, you done the kth step. So now we can have a general understanding of the kth step. We know that k varies from 1 to n. So what relate some of that process from 1 to n, plugging every value. You know, we get yeah,
That's what you're getting.
yeah.
Okay.
Yes, I have office hours going now for the next couple hours.
Alright, sweet. Well,